In this video, we will discuss about how this alternate binding domain in the car engineering evolved. So, when the car engineering idea has been uh, first come into place, then they started with this single chain variable fragment antibodies. So, basically, what they did is they took the uh, variable fragment of the antibodies that can target these tumor associated antigens, and then recombinant it in the car construct in the extracellular domains that is shown in this top left side of this single chain variable fragment. And however, the problem with this single chain variable fragment is that its size is too big and it also has the multiple domain, and that will create improper folding, and in some case it might even leads to tonic signaling within the CAR T cells without it's been activated or in the single chain variable fragment interactions with the tumor associated antigens. In order to counter these problems, the researchers has developed this nanobody, which is commonly known as nanocar, where the extracellular domain size is very small and it can interact with these tumor associated antigens. However, the problem with this is that the tonic signalings are that are triggered are very low, and it will cause a very low anti-tumor effect whenever it comes in contact with the tumors. So this is another problem. Thereafter, they developed these scaffold folds, different kind of scaffold proteins, and the basic idea is that their size is even smaller than the nanobodies. However, what it will does is it can interact with these tumor associated antigens and can release and are hypersensitive towards this tonic signaling releasing. And because of that, what will happen is that this in some cases, because of the hypersensitivity, it might has some side effects like immunogenicity effect. And because this and these scaffold proteins that are made from non-traditional methods, so they are always prone to give some immunogenic reactions, as they are not humanized optimized. So it also has a problem. So in order to counter that, the researchers now focus towards these receptors, ligands, and cytokine derivative. So in this case, what will happen is that in the case of cytokine derivatives, the instead of any like variable fragment or tumor associated antigen that are expressed on the cellular domains, a cytokine binding domains are been expressed in the cellular domains. For example, interleukin 12. So when it interact with the tumor cells, it will triggers the interleukin 12 formations, and that might cause a anti-tumor effect. That might has an anti-tumor effect against the cancer. And the advantage of this is that even the cancer cells that does not or that has lost this antigen, that does not have the antigens uh, against which the CAR T cells are designed. The CAR T cells are designed, different domains of the CAR T cells are designed. Even in that case, these cytokines based the cytokine based CAR Ts or cytokine derivatives of the CAR Ts has a better effect, better anti-tumor response against those cancer cells. And the other kind of CAR T binding domains are used is the receptors, and receptors on the CAR T sites and ligand on the cancer cells, receptors on the cancer site and ligand on the CAR T sites. So this can be used interchangeably. However, these things are or the CAR Ts with this kind of binding domains, that is receptor, ligand, cytokines, are in the clinical trials. However, these scaffold proteins, because of their sensitivity, there is not much clinical trial has been done, and this scFv, as we know, it might cause cause a side effect by generating a non-specific tonic signaling. Nanobody has a very low effect, very low antitumor response. So currently, these kind of binding domains, CAR contains these kind of binding domains, that is receptors, ligands, cytokines, are under clinical trial. I hope you understood different alternate binding domains and their history and how they have evolved. If you need to understand more about their topic in details, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.